Hello everyone, my name is Nidhi Singh. I'm assistant professor in Gyan Vihar School of Pharmacy, that is a part of the Suresh Gyan Vihar, Jaipur. So today we will discuss the topic that is the carboxylic acid, and this we will discussing about the carboxylic acid derivatives, and this is in your pharmaceutical or chemistry first. So let's start. So the learning objectives today's topic is your sorry about the carboxylic acid derivatives, that what is the carboxylic acid derivative and what are the chemical reactions of carboxylic acid derivatives, and also we are going to discuss about first about the carboxylic acid derivatives, and the student outcomes is that we will going to know what are the carboxylic acid derivatives are, and secondly they will also learn about the carboxylic chemical properties of this carboxylic acid derivative. So in the last lecture, I've already told you that what is the carboxylic acid derivative properties, what are the physical properties of your carboxylic acid derivatives, what are the relative stabilities of this carboxylic acid derivatives, and the stereochemistry also I've already told you. And we have already discussed the method of preparations of carboxylic acid derivatives. So in the carboxylic acid derivatives, we have already discussed the carboxylic acid derivative method of preparation, in which we have discussed the method of preparations of your acid chloride, acid anhydride, acetamide, and your esters. So here today we are going to discuss about these carboxylic acid derivatives. That what are the carboxylic acid derivatives? Introduction, I'm giving you a small brief introduction in which let's start. Firstly, let's discuss the topic. So in this, the introduction is that the carboxylic acid derivatives. So the most important functional derivative of carboxylic acid are ethyl chloride, acid anhydride, esters, and amides. So in this, the most important functional derivative of carboxylic acids are ethyl chloride, acid anhydride, esters, and amides, which are obtained by the replacement of OH part of carboxyl group of acid by Cl, OCOR, OR dash, or NH2 group respectively. So in this, we are what we are doing in this, the carboxylic acid, which is a mixture of your formation which are formed. The carboxylic acid is formed from the two function group, that is the carbonyl and the hydroxyl group. So in this, the both are comes, and the name carboxylic acid also comes from both of them. Then the carbo comes from the carbonyl part, and the acylic comes from the hydroxyl part. So here it becomes carboxylic acids, and the carboxylic acids are also the member of the carbonyl compounds, that is the acetaldehyde. So these are also the member of that carbonyl compound, because all of the carboxylic acid derivatives they are also containing the carbonyl part, that is your COO. So COO is the carbonyl part, and this carboxylic acid, from the carboxylic acid, their derivatives are formed, that is why they known as carboxylic acid derivatives, and that is why they are all the carboxylic acid derivatives, because they are formed from the carboxylic acid. And in the carboxylic acid, you can see there is an alkyl part on the one side of the carbon atom, or on the other side there is a hydroxyl group, and this carbon is attached to the oxygen with the double bond, and the single bond is attached to the alkyl part and the hydroxyl part. So from this carboxylic acid, there is a formation of the carboxylic acid derivative. So from the carboxylic acid, this OH is replaced. This OH is replaced by the different function groups, and then there are four important carboxylic acid derivatives are formed, that are your or acid chloride, or you can say the acyl chloride, acid anhydride, esters, and the amides are formed from this. These are the four important functional derivatives of the carboxylic acids, and they are having the functional formula, or you can say this formula, that is your RCOCl. So RCOCl is the functional formula of this ethyl chloride, and they are having RCOCl. And in case of a acid anhydride, they are having the formula that is your RCO whole twice O. In ester, that is having the RCO R dash, where R and R dash may be same or different. So in this ester, there are two alkyl groups are attached, or you can say the two R are attached to this COOR. So these both of these R can be different, or these can be same. So both of them, both of the R can be same or they can be different. And they, and the fourth is your amide, which is also the important class of this important functional derivative of this carboxylic acid. So the important functional derivative of this carboxylic acid are your ethyl chloride, acid anhydride, esters, and the amides. And these all are obtained by the replacement. These all are obtained by the replacement of the OH group, OH part from the carboxyl part of the acid by your Cl, OCOR, OR dash, in H2 group respectively. So in case of your acid chloride, this OH is replaced by the Cl part, and then they are called your acid chloride. Next, in the next case, the OH is replaced by ethyl oxy, and they are known as acid anhydride. So in the carboxylic acid, the third important functional derivative of this carboxylic acid is your esters. So in the esters, this OH is replaced by the OR dash. So R is the alkyl, so that is known as alloxy. So in the esters, the OH is replaced by the alloxy part, and then it becomes the ester. So next is your fourth class, that is the fourth derivative of this carboxylic acid. So in this fourth derivative of this carboxylic acid, the OH has been replaced by the NH2. So NH2 replaces the OH, and then it becomes the amide. So in this, these are the four class of this functional derivative of this carboxylic acid, that is your ethyl chloride, in which the OH is replaced by the Cl, and it becomes the first derivative, important derivative, functional derivative of the carboxylic acid, that is your acid chloride. Next is your acid anhydride, in which the OH is replaced by the ethyl oxy, that is your OCOR. So this replaces this OH, and it becomes the second important functional derivative of this carboxylic acid. And the third is your esters. So in the esters, this RCOOH, in the carboxylic acid, OH has been replaced by the alloxy. This alloxy, that is your OR dash, and it becomes your esters. And the fourth most important functional derivative of carboxylic acid is your amide. So in this, in the carboxylic acid, the OH has been replaced by the NH2, and it becomes the amide. So these all functional derivative of carboxylic acid has been obtained, which these all are obtained by the replacement of the OH part of the carboxylic group of acid, that is your carboxylic acid. From the carboxylic acid, this OH is replaced by the different functional groups, or you can say the atom, or this that is your Cl, OCOR, OR, or NH2 groups in the ethyl chloride, acid anhydride, and the esters and the amide respectively. So the next is your first. In the last lecture, we have discussed the chemical reaction of your acid chloride. So this is the seventh method. We have already discussed the sixth method of the acid chloride. The first is your basic character. Second was the reduction. Third is the action of the third, fourth, and the fifth, in which the amines are converted into the amides, and this acid chloride is converting into the amines. And seventh is the action of hydrogen. Means here on treatment with hydrogen, acid chlorides form hydroxides. So here hydrogens are reacting with the acid chloride, and there is a formation of the hydroxides are formed plus HCl is formed. So here example is given that acid chloride, this is the RCOCl plus H2N NH2. So this is the hydrogen. The formula of hydrogen is your NH2. So here the hydrogen is reacting with the acid chloride and there is the formation of the hydroxide. So hydroxide plus HCl is formed. So in the chemical reaction of acid chloride, you have seen that there is also a formation of HCl from this acid chloride, whatever the reagent is it, but the product is formed, the main product plus your HCl is also formed in this. So in this, the action of hydrogen, the acid chloride is reacting with this hydrogen, which is having the formula NH2. So in this NH2 is reacting with this acid chloride and there is a formation of this hydroxide plus HCl is formed here. So in this, you can see the example is given, this acetyl chloride is given. So or you can say ethanol chloride is reacting with the hydrogen and there is a formation of this your ethanol hydroxide plus HCl is formed here. And when benzoyl chloride is formed, is reacted with this hydrazine, then there is a formation of this phenyl hydrazine plus HCl is formed here. So here in the reaction, you can see when the action of hydrazine is reacting with this acid chloride. Okay, when acid chloride, hydrazine is reacting with this acid chloride. So there is a formation of this hydrazide and in this you can see in the ethanol chloride plus your hydrazine. You can see here from here one H is removed out, H positive, and here it becomes a negative, and here it becomes a positive, and here it becomes a negative. So this negative Cl and this H positive will react and there is a formation of this HCl, and this negative NH2 and CH3CO, that is a positive, it will react and there is a formation of the bond between the carbon and the nitrogen, and here it becomes the hydrazide. So here the hydrazide is formed. Similarly, in case of your aryl, means in your benzoyl chloride, in this the benzoyl chloride, this Cl is removed out from here and there is a positive charge on this carbon atom. And from here, this NH2, this nitrogen is having this H is having the positive charge with one single proton is dissociated from here, and there is a negative charge on this NH2, and this H is having the positive charge. So this positive charge, this proton will react with this chlorine, and there is a formation of this HCl, and this negative N and this positive C will react, and there is a formation of this phenyl hydrazide is formed. So in the action of hydrazine on treatment with hydrazine, acid chloride forms hydrazide. So next is the action of hydroxyl amine. Means here the hydroxyl amine is reacting with the acid chloride and there is a formation of hydroxylic acid. So here acid chloride is reacting with hydroxyl amine. The hydroxyl amine is your hydroxyl amine formula, means here the hydroxyl group is also attached and the amine is also attached, so it becomes hydroxyl amine. So in this, the hydroxyl acid chloride is reacting with the hydroxylamine, that is your NH2OH. So here you can see OH is also an NH2. So its name is hydroxylamine. So in this, the acid chloride is reacting with this H2NOH, that is your hydroxylamine, and there is a formation of this hydroxylic acid. So hydroxylic acid is formed plus HCl is also formed. So in the last reactions also HCl is formed, and in this reaction also this HCl is formed. So from here, from here you can see that the HCl is evolving out from here. Means it is removed out from the both the reagents. Means from one the HCl and from one the proton is removed out. So in the second, that is your CH3COCl plus NH2OH. So in this you can see acid chloride is reacting with this hydroxylamine. This is ethanol chloride, and this ethanol chloride is reacting with the hydroxylamine, and there is a formation of this hydroxylic acid. So hydroxylic acid is formed here, plus your HCl is also formed. Next is your benzoyl chloride. So in the benzoyl chloride, hydroxylamine is formed, and there is a formation of hydroxylic acid, or you can say benzoyl hydroxylic acid is formed plus HCl. So in the first reaction, that is your seventh reaction, that is your action of hydrogen. In this, the treatment of your hydrogen acid is this treatment of your hydrogen acid chloride forms hydrazide. So in this, the hydra from the hydrogen is getting converted to the hydrazide when it is reacting with the acid chloride. So here the acid chloride is reacting with the reagent, and there is a formation of a hydrazide. So here example is given, ethanol chloride is reacting with this hydrogen, which is having a formula NH2NH2, and there is a formation of this hydrazide is formed here. CH3CONH2 plus HCl is formed here. And in the next, that is your benzoyl chloride. In benzoyl chloride is reacting with this hydrogen, that is your NH2. Then there is a formation of this phenyl hydrazine is formed here. So here phenyl hydrazine is formed with the reaction of this benzoyl chloride with the hydrazine, and there is a formation of the phenyl hydrazine plus HCl is formed here. And this is the seventh method, which is the action of hydrogen with the acid chloride, and there is a formation of this hydrogen is getting converted to the hydrazide. Next is the action of hydroxyl acid. So in the action of hydroxyl acid, there is a reaction of hydroxylamine. Hydroxylamine is reacting with the acid chloride, and there is a formation of the hydroxylic acid. Means here oxalic acid is formed here from the reaction of this hydroxylamine, which is having the formula NH2OH. So it is having the both functional group, that is amine NH2 and your hydroxyl, that is having OH. So both so the hydroxylamine is transforming into the hydroxylic acid. So hydroxylamine is getting converted to the hydroxylic acid. So in this, acid chloride is reacting with this hydroxylamine, and it is getting converted to the hydroxylic acid plus your HCl. So here you can take the example, that is CH3COCl plus NH2OH and CH3CONH plus HCl is formed. So here see this COCl plus NH2OH is getting converted to your CONH plus HCl is formed here. So next is your action of ethers. So in this, the ether, your action acid chloride on reaction with diethyl ether in presence of zinc chloride, it formed esters. So here acid chloride on reaction, acid chloride is reacting with the diethyl ether in presence of zinc chloride, and there is a formation of your ester. So ninth reaction of this Acid chloride is the action of ether on the acid chloride, and this acid chloride is reacting with the diethyl ether, which is the ether, and which is a type of ether, and this reaction is happening in the presence of zinc chloride, and zinc chloride is acting as a catalyst, and they are forming esters. So here in the reaction, you can see that CH3COCl plus C2H5O. C2H5 is your ether, that is your as diethyl ether. So this diethyl ether is reacting with the acid chloride in the presence of the zinc chloride, and there is a formation of the ethyl acetate plus your ethyl chloride. So here in this reaction, there is no formation of the HCl is there, but there is a formation of a ethyl chloride plus your ethyl acetate is formed here. So in the action of ethers, the acid chloride is reacting. This acid chloride is reacting with the diethyl ether, and there we are getting we are getting this ethyl acetate plus in the presence of the catalyst, that is the zinc chloride. So here in this, the derivative that is your derivative of carboxylic acid is getting converted into the parent carboxylic acid. So this is your ethyl acetate. Okay, so here the acetate is formed here. So this is the ninth reaction of this acid chloride, chemical reaction of this acid chloride, and in this the acid chloride is reacting with the diethyl ether, and there is a formation of ethyl acetate and your ethyl chloride. So in the reaction, you can see that CH3COCl plus C2H5O. This is your two reactant, and if these reactants are reacting in the presence of your zinc chloride, and there is a formation of this ethyl acetate plus ethyl chloride is formed. So this is the acid chloride. This is CH3COCl plus diethyl ether. This is your C2H5O. So in this, you can see CH3COCl is reacting with this C2H5O, and there is a formation, there is a formation of this acetate, there is a formation of this acetate is there, there is a formation of acetate is happening. This is your CH3COO, C2H5, CH3COCl, the C2H5O, C2H5, this is CH3CO. This is reacting with the C2H5O, and this is your positive. When this is dissociated, then there is a formation of the CH3CO positive and Cl negative, and in this case C2H5O negative and C2H5 positive. So this C2H5O negative will react with the positive CH3CO, and there is a formation of this ethyl acetate. Second product is your C2H5, which is your positive, and this will react with the chlorine, which is having the negative charge, and there is a formation of this ethyl chloride is formed here. So this acid chloride is reacting with the diethyl ether in the presence of zinc chloride, and there is a formation of a ethyl acetate plus ethyl chloride is formed here. Next is your benzoyl chloride. So the benzoyl chloride is reacting with this C2H5, that is your diethyl ether, and this aryl compound is reacting with this diethyl ether, and there is a formation of this phenyl ethyl acetate is formed here, plus C2H5Cl, that is your ethyl chloride is formed here. So in this also, in the aryl compound also, the same thing is will be happen. So in this there is a dissociation, and this dissociation will occur from this side, and this will get the negative and this will get the positive charge. CH2H5O negative and C2H5 positive. Next, in there is a dissociation, and there is a formation of this here. From it will get dissociated from. So this will get the positive charge, and this Cl will get the negative charge. So this Cl negative charge will react with this C2H5 positive charge, and there is a formation of this ethyl chloride, and this this positive CO, C6H5CO positive will react with this C2H5O negative, and there is a formation of this phenyl ethyl acetate is formed. Next is the action of potassium cyanide. So here the action of potassium cyanide. So the acid chloride is reacting. So the acid chloride is reacting with the potassium cyanide, and there is a formation of acetyl chloride. Sorry, this acid chloride is reacting with this potassium cyanide, and there is a formation of this. There is a formation of acetyl cyanide, which on acid catalyzed hydrolysis give pyruvic acid. So this the reaction of this acid chloride is reacting with this potassium cyanide. That is why this is the 10th step that is showing that the action of potassium cyanide. So here the action of potassium cyanide on acid chloride forms acetyl cyanide, and this acetyl cyanide is reacting, or there is an acid hydrolysis is happening, and after the acid hydrolysis with this acetyl cyanide, there is a formation of the pyruvic acid. So there is a formation of the pyruvic acid is there. So this CH3COCl, this is the acetyl chloride, which is reacting with your KCN, and here from here there is a removal of the KCl, and there is the formation of the CH3COCN, which is the acetyl cyanide, and on this this acetyl cyanide is which on acid catalyzed hydrolysis, it is forming it is giving pyruvic acid. So it is giving a pyruvic acid. So in this, acid chloride is reacting with the potassium cyanide, and there is a formation of acetyl cyanide, which on acid catalyzed hydrolysis give pyruvic acid. So in this, you can see this is your acetyl chloride, this is the acetyl chloride, and it is reacting with this potassium cyanide, and there is a formation of this acetyl cyanide, and this is on hydrolysis, acid hydrolysis, acid catalyzed hydrolysis, pyruvic acid is formed here. So pyruvic acid is formed here. So here in the CH3COCl plus KCN, what happens in this reaction? That there is a dissociation from here, and here there is a dissociation here. So in this, CH3CO will get the positive charge, Cl will get the negative charge, partial negative, partial positive, and in this KCN, this K will get the partial positive charge, and Cl will get the partial negative charge. So this partial negative KCN will react with this CH3CO positive, and there is a formation of this acetyl cyanide, and from this this Cl negative will react with the K positive, and there is a formation of this KCl, which is removed from this reaction. After that, this acetyl cyanide is hydrolyzed with this acid catalyzed, means this acid portion of this H positive is catalyzing the reaction, and there is a formation of this pyruvic acid. So there is a formation of this pyruvic acid is formed here. So in this, you can see this is your CH3COCN. Here are the two molecules of this H2O, and from here this OOH is reacted here. So this OOH is reacted here, and there is a formation of this pyruvic acid, and from here NH2 is removed from here. So from here NH3 is removed out from here, because here only one H is used and O2O is used. So here NH3 is removed out from. So there is a formation of this pyruvic acid is formed here when the acid chloride is reacted with the potassium cyanide, and there is a formation of this acetyl cyanide that is having the formula CH3COCN, and this CH3CON, which is of acetyl cyanide, which is acid catalyzed hydrolysis, which on acid catalyzed hydrolysis gives your pyruvic acid. So this is the 10th reaction when acid chloride is when potassium cyanide is showing its action on the acid chloride. Next is your reaction with the Grignard reagent. So in this, acid chloride is firstly showing reaction with the Grignard reagent, and it gives tertiary alcohol. So this acid chloride on reaction with the Grignard reagent, it gives tertiary alcohols, and there is a formation of this acetyl chloride, and there is a formation of this acetyl chloride, and this acetyl chloride is reacting with this Grignard reagent, which is your alkyl magnesium chloride. That is your methyl magnesium chloride, and this methyl magnesium chloride is reacting with this acetyl chloride, and there is a formation of this acetone plus magnesium chloride is formed here. So there is a formation of this magnesium chloride is formed here, and and in this firstly, what we have to do, we have to prepare the Grignard reagent. So Grignard reagent is formed by the reaction of your alkyl halide with the magnesium. When your alkyl halide is reacted with your magnesium, that is a metal, there is a formation of a alkyl magnesium halide. So this alkyl magnesium halide is your Grignard reagent, and this alkyl magnesium halide on reaction with the acid chloride, it forms your tertiary alcohol. So it gives tertiary alcohol on reaction of the acid chloride with the Grignard reagent, and there is a formation of acetone. So in this case, there is a formation of acetone is there, and acetone is reacted. Acetone is reacted, and there is a formation. There is a formation of acetone, and there is a formation of acetone, and plus magnesium chloride is formed here. So here, example is given that ethanol chloride is reacted with this Grignard reagent, and there is some intermediate is formed here. So this intermediate is your CH3, CH3, Cl, OMgR, and when there is a hydrolysis happening here, then there is a formation of this acetone plus your magnesium chloride or magnesium bromide chloride is formed. So in this case, you can see, you can take the chlorine also, or you can bromide also can take here. So in this, there is acetyl chloride, and this acetyl chloride is reacting with this Grignard reagent, and this Grignard reagent comes from the reaction of the your alkyl halide with the magnesium. That is your magnesium is your metal, and when the alkyl halide is reacting with the magnesium, there is a formation of a Grignard reagent, that is your alkyl magnesium halide. So here alkyl group is attached to the metal, and the chlorine is also attached to the metal part. So here you can see that this is your CH3COL, which is your ethanol chloride, and this ethanol chloride is reacting with this ethanol chloride or acetyl chloride is reacting with the methyl magnesium chloride, and there is a formation of this acetone. So how it is formed? It is formed here like So in this, the CH3COCl, the Cl MgCr. So this Cl is having the positive charge, and this is having the negative charge, and metal is having the positive charge. And this Cl is having the negative charge, and CH3CO is having the positive charge. So here, this methyl, which is having the negative charge, it gets attached to this carbon. This carbon, that is your CH3CO. CH3, there is a formation of this acetone, and in this, the Cl, which is having the negative, and this MgCl is having the positive, it gets reacted, and there is a formation of this MgCl2. So next here, we have used acetyl chloride, or we can say ethanol chloride, and when this ethanol chloride is reacting with this methyl magnesium bromide. Then there is a formation of this intermediate is formed. This is your CH3. C on this C, this CH3, the CH3 is getting attached to it, and on the oxygen, with the oxygen which is having the negative charge, and this MgBr is having the positive charge, it get attached to this negative oxygen, and there is a formation of this intermediate. After that, there is a hydrolysis. There is a hydrolysis is occurring here. So there is a hydrolysis is occurring here, and this hydrolysis, on hydrolysis, there is a magnesium. There is a this magnesium BrCl is removed out from here. Sorry, this magnesium BrCl is removed out from here, and there is a formation of this CH3 COCH3 is formed here. That is your acetone. So here, from here, the CCOCH3, this is here, and from here MgBrCl is removed out from here. This whole is removed out from here, and there is a formation of this acetone is here. Acetone is formed here. Next is your action with halogen. So here, what will happen when the acid chloride is reacted with the chlorine to form monochloroacetic acid? So here, this this acid chloride is reacted with the chlorine, and there is a formation of a monochloroacetic acid. So monochloroacetic acid with chlorine form monochloroacetic acid. So this action with halogen. So here in this, the action of halogen, the acid chloride is reacting with the chlorine, and there is a formation of monochloroacetic acid is formed here. So here we have taken this propenyl chloride, or you can, yes, you can say the propenyl chloride, because it is having the 3 carbon atom. So it is your CH3, CH2, CuCl, and it is reacting with the chlorine, and there is a formation of this chloropropenyl chloride. So from here, one ash is removed, and this ash is getting reacted with this chlorine, one chlorine, and there is a formation of this HCl. So in this, the action of this action with halogen. So this acid chloride is reacting with this chlorine, and there is a formation of a monochloroacetic acid. So the monochloroacetic acid is reacting, and there is a this monochloroacetic acid is formed by the reaction of the acid chloride. Acid chloride is reacting with the chlorine, and there is a formation of a monochloroacetic acid. So this is the CH3, CH2, COCl plus Cl2, and there is a formation of the CH3, CHCl, OCOCl. So this is your chloropropenyl chloride. So in this, you can see there is an action with halogen. This is the 12th method of the preparation of your halogen, and in this, the acid chloride is reacting with the chlorine, and there is a formation of the monochloroacetic acid. So in this, the monochloroacetic acid is formed here. Sorry, this monochloroacetic acid is formed here, and in this, the propenyl chloride, this is the 3rd member of this acid chloride, and then this propenyl chloride is reacting with the chlorine, and there is a formation of a chloropropenyl chloride plus HCl. Next is a reaction with carboxy acid. So here we are treating it with the parent carboxylic acid. So this derivative is reacting with the carboxylic acid, and there is a formation of a pyridine. So there, the acid chloride is reacting with the carboxylic acid in the presence of pyridine to form acid anhydride. So in this, the acid chloride is reacting with the carboxylic acid, and in the carboxylic acid, and this acid chloride is getting converted to the acetic anhydride in the presence of pyridine, plus HCl is also formed here. So this is the 13th reaction of this carboxylic acid, and in this, this is the derivative of this carboxylic acid, and when the derivative of carboxylic acid is reacting with the carboxylic acid. This is the parent carboxylic acid, and in the presence of pyridine, there is a formation of this acid anhydride. So acid anhydride is formed, and so in this, acetyl chloride is reacting with this CH3COOH in the presence of your pyridine, and there is a formation of your acetic anhydride. So here you can see in this reaction is what is happening, that CH3COCl, that is, if we are dissociating it, then there is a CH3CO positive plus Cl negative, and in this CH3CO negative plus H positive. And here you will see this H and Cl will react, and there is a formation of this HCl. So there is a formation of this HCl is formed. So in this, there is a CH3CO. CH3CO is common. So here the two molecules of the CH3CO is formed. That is why we have used here bracket by the two CH3CO whole twice, and this oxygen is alone, and there is a formation of this acetic anhydride. This is your CH3CO whole twice. Next is your acetyl chloride, and this acetyl chloride is reacted with this acetic acid, and this acetic acid is reaction with this pyridine, and there is a formation of this acetic anhydride. So this acetyl chloride is reacting with this acetic acid in the presence of a pyridine, and there is a formation of this acetic anhydride is formed here. So this is your benzoyl chloride, and this benzoyl chloride is the same. In this, there is a, this is your Cl is removed, and this Cl will react with this H, and there is a formation of this HCl, and this whole CO will react with this OCOCH3. This whole will react with this whole phenyl CO will react with this CH3COO. So here you can see OCOCH3 is attached. So next is your 14th reaction. This is your Friedel-Crafts reaction. So in the Friedel-Crafts reaction, the acyl chloride is reacting with the aromatic hydrocarbon in presence of Lewis acid, that is your aluminium chloride, in Friedel-Crafts acylation, and there is a formation of aromatic ketone. So here in the Friedel-Crafts reaction, acyl chloride, the acyl chloride, or you can say the acid chloride, is reacting with the benzene. So it is reacting with the aromatic hydrocarbon, or you can we have taken here benzene in the presence of your Lewis acid. In the presence of your Lewis acid, that is your AlCl3, aluminium chloride, in Friedel-Crafts acylation. This is the Friedel-Crafts acylation, and there is a formation of your aromatic ketone is formed here. So aromatic ketone is formed here. So in the acyl, so here you can see the aromatic hydrocarbon, which is your benzene, and this benzene is reacting with this CH3COCl, that is your, or CH3COCl, that is your acid chloride, and it is reacting with this acid anhydride AlCl3, that is a Lewis acid, and there is a combination of this ketone. This ketone is your acetophenone, which is a aromatic ketone. So here aromatic ketone is formed from the reaction of aromatic hydrocarbon. We have taken a benzene with the acid chloride in the presence of your Lewis acid, that is your anhydride AlCl3, aluminium chloride, and there is a formation of this HCl is formed. Next is the uses of acyl chloride. So the acyl chloride used in the preparation of acetic anhydride, acetamide, and acetanilide, and as acetylating agents in many reactions, and they are also used in the detection and determination of OH, NH2, NH, and functional groups in a molecule. So this acid chloride or your acyl chloride, these are used in the preparation of acetic anhydride, acetamide, and acetanilide, and as acetylating agent in many reactions. So and they are also used in the determination and the detection of this OH and primary amine, a secondary amine, and the functional group in a molecule. So this is used as a this acyl chloride is used in the determination and the deduction of various functional groups. So next is the question. So next is the question. So anhydrides can be converted in ester by the reaction of your alcohol. So the reduction of acetyl chloride with BDPSO4, that formation of acetaldehyde. So on reduction with lithium aluminum hydride, there is a production of your alcohol. So on reaction with thionyl chloride, ester can be converted into your acid and chloride. Next is your with lithium aluminum hydride, amide reduces to acids, and the acid and hydride can be converted into esters with the amines. And acid amides can be obtained by either partial hydrolysis of acid cyanides, and on reduction with ethanol, it produces alcohols. So these are some of the references from where you can study this topic, and thank you so much for today's lecture.